Hey everyone. So here we're starting our unit circle. Okay. So this will be broken up into parts. So the goal for today is making sure that you guys know how to get the degrees and the radians at each point. Okay. And then eventually we'll get to the coordinates, but one step at a time. Okay. So you should have two things in front of you. You should have this packet. I sent you a PDF. Make sure that you print it out. And if you can't print it out, you can just draw it out. Okay. And secondly, your trig table. You guys did this last week. Okay. And I assume that you've had a chance to take a look at each value to make sure that it's accurate, but also that you were given time to look at potential patterns. Okay. So here's how the unit circle works. It's pretty much an organized way of getting all of our values here in the trig table onto this circle. Okay. So what happens here, just so you understand how this works first, this is really your X and Y axes. Okay. So this right here is really your X and Y axes. So this is really just a graph, right? So you're getting a drawing with a bunch of points on it on a Cartesian plane, which is the X and Y axes. And it's pinpointing, or it's taking several snapshots of what would happen if your angle was a particular degree or radian. So for instance, remember when you were drawing reference triangles, if we were to open it up 30 degrees, we would stop here. We would draw a line, and then you would hug the x-axis, and then you would go on your way figuring out the sides of each of those parts in a triangle there, okay? Now, if you were to go out 45 degrees, then you would sweep out somewhere about the middle here, and then you hug the x-axis, and then that would be your 45 degrees. Or, I know I'm making it a little bit messy here, but if you were to open it up 60 degrees, then you would just go out there, hug the x-axis. So, like, you don't get to see all of these triangles, but that's what's happening behind the scenes. Okay? So, the first thing you want to do is you want to be able to identify the angles in degrees and radians, okay? So, you want to go in this particular order. So right now, what you want to do is you want to put your pencil or pen down, okay? You don't want to do this while I'm doing it, all right? So here we go. We're not writing anything down. Press play when you're ready. Okay, so the first thing you want to do is you want to identify the easiest angles. So these are your quadrantal angles. So we're going to start at 0 degrees. I know that if I go half a circle, so if I go half a circle, I'll end up at this point, and this will be 180 degrees. Okay, and if I continue to go counterclockwise, another semicircle, I'll be back at 360 degrees, which is coterminal to 0 degrees. They're the same thing because you end up in the same spot. Okay? Okay, well, if I go halfway, I know that this is going to be 90 degrees. Right? I won't draw those arrows. So notice how every quadrant that you travel, you're traveling 90 degrees. So this one must be 270 degrees. That's the first thing you want to do. Okay? Again, you're just watching, you're not writing this down. Every quadrant has 3 points because there's only a certain amount of special angles that we're going to use. We're only going to focus on those special angles. Okay? So here's what you do. You focus on the middle one first. This middle one here is the bisector from 0 to 90. Or in other words, it's the halfway mark. So halfway from 0 to 90 is really just 45 degrees. So if you want to think of it this way, every half of a quadrant, you're traveling 45 degrees. So what would it be if we were to continue going halfway each time? Okay, so notice how when I go another 45, I'm adding 45 to it, and then I get 90. If I add another 45 to it, this should be 135. If I add another 45, I get 180. Fill out the rest and press. Actually, you know what? Don't do that because you're just watching. Okay, if you add another 45 here, this will be 225 degrees. You add another 45, you get 270. You add another 45, you get 315 degrees. And then another 45 will get you back to 360. But you're not going to draw those arrows. That's really to get you to understand what direction we're going in. Okay? Okay, so notice how there's only 2 angles left in each quadrant, right? Let me get rid of all these here so you don't get distracted. Okay. This one is pretty easy because these are in regards to the 30 and the 60, 90 degree special right triangle. So you pick a quadrantal angle, for instance, 90 degrees, okay? If you go backwards, we're going to subtract 30 degrees. If we go forward, we're going to add 30 degrees. And by forward, I mean counterclockwise, okay? So if I go back, this should be 60 degrees. If I go forward, that should be 120 degrees. Okay. At 180, if I go back, that should be 150. If I go forward, that should be 210. At 270, if I go back, that's really just 240. And if I go forward or counterclockwise, that should be 300 degrees. And if I go back from 360, that'll be 330 degrees. And if I go forward from 0, that'll just be 30 degrees. Let me go ahead and clean this up a little bit so that you can see what you just did or what you're about to do. Okay, so right there we have the 4 quadrantal angles. We have the 3 angles in each quadrant. That's a total of 3, 6, 9, 12, 16 points. Okay, so these are your special angles. All right. Okay, now pause here, pick up your pencil, and fill it out without looking at this. So minimize your window so that you don't see the angles. And then work it out. And if you forget something, press play, and then we'll take a look, okay? Okay, so right there, you want to try that as many times as possible. At the very end of this packet, you'll notice that there's a lot of blank ones. That's really for you to try, okay? Okay. So for this one here, before we jump onto radians, notice how all of the angles, 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, 360 are all right here. Okay? From 0 all the way to 360. So that's how we get those special angles. Okay, you start with the quadrantal angles, and then you go midway, and then you deal with your 30s. Okay? All right, so how do we actually get the radians now? Right? So we're going to do the same thing. I'm going to go ahead and you don't have to erase yours because you want it in front of you, okay? I'm going to go ahead and erase it because I just need more space. So you can write around it. That's totally fine. But here we go. What you do, just like with degrees, with radians, you start at the quadrantal angles. So again, you start off with basic stuff that you know. So for instance, 0 degrees is the same thing as 0 radians, okay? I know that if I were to travel a semicircle, that is 1 pi. Because remember, 1 pi is equivalent to 180 degrees. 1 pi radians. So if I travel another semicircle, that's really 2 pi. So 0 and 2 pi are coterminal angles. Okay, they're equivalent in the sense that they end up in the same spot. Okay? All right. Now, what if I just go half of a semicircle? So that would just be half of a pi. So notice how that's 1 pi over 2, 2 pi over 2. But if you clean that up, that's really just pi. So if I travel another 1 pi over 2, that'll be 3 pi over 2. to 4 pi over 2, but really 4 pi over 2 is just 2 pi, all right? And again, you don't have to draw the arrows. It's to make sure that you guys are going in a counterclockwise motion, okay? Now from here, there are a lot of patterns. I'll show you 2 of the ways. I notice that in quadrants 1, okay, I notice that pi over 6, pi over 4, and pi over 3 all have pi in it, but it goes 6, then 4, then 3. I'm going to go ahead and put 6, then 4, then 3. I have to go in order counterclockwise, okay? And if you're ever unsure, remember pi is 180 degrees. So for instance, pi, or 180 divided by 6, that's really your 30-degree mark, which is what you guys have on paper, okay? Okay, now some of you noticed that the other quadrants, not including the quadrantal angles, but they also have a 6, a 4, and a 3. So here, let me highlight it in case you didn't see it. Notice how there's a 6, a 4. Let me scoot this over here. 6, a 4, and a 3, and then a 3, a 4, and a 6, and then a 6, a 4, and a 3, and a 3, a 4, and a 6. Kind of like oscillates. It's kind of like a palindrome, if you know what that is. It's like when you read it backwards, it's the same word. So it goes 6, 4, 3, 3, 4, 6. 6, 4, 3, 3, 4, 6. Okay? So take a look. What I'm going to do here is, I know that all of the numerators have pi in it. So I'm just going to put a pi there. Okay? So once again, it's 6, 4, 3, 3, 4, 6. Okay, so once again, I'll draw arrows so that we can see. 6, 4, 3, 3, 4, 6. 6, 4, 3, 3, 4, 6. Okay, oscillates. So let me go ahead and get rid of that. So here's what we do. So 6, 4, 3, 3, 4, 6. 6, 4, 3, 3, 4, 6. Okay? Now, some other things to kind of consider. I noticed that if I were to draw a line at pi over 6, I end up with something across that's also over 6. They kind of line up there, right? I noticed that when I look at pi over 4, it matches up with something that's pi over 4. Same thing here. Pi over 4 matches up with something that's pi over 4. So whatever it's diagonal to, you notice that it has the same denominator, right? And similarly, I won't do all of them, but pi over 3 opposite is pi over 3 as well. So you follow that line, okay? So there's a pattern there. But here's the thing. In quadrant 2, these are not my angles. You know, in my circle, I have pi over 3, pi over 4, pi over 6. But in my table, I have 2 pi over 3, 3 pi over 4, 5 pi over 6. Okay? 2 ways that you can handle this. I'll show you the logical way, then I'll show you the shorter way, okay? Okay, so I'll use green here. So remember, pi over 3, all of these radians are an angle. So for instance, if I traveled 1 pi over 3, this would be 2 pi over 3. So I would put a 2 there, okay? And if I travel another pi over 3, that would be 3 pi over 3. But 3 pi over 3 is really just pi, which is a semicircle. So you can count that way. That's the logic behind it. But actually, one of my former students came up with this pattern. Feel free to use it. He or she or they noticed that when you're in quadrant 2, the numerator is always 1 less than the denominator. So for instance, if the denominator is 3, the numerator would be 1 less, right? If the denominator was 6, the numerator was 1 less. So I put a little -1 here to remind myself, okay? So there, that would just be 2 pi over 3, 3 pi over 4, 5 pi over 6. And that's how you guys remember it, okay? Now, when you get to the third quadrant, think about what that pattern is there. Okay, so you notice that it's not 1 less, it's actually 1 more than the denominator. So I'll put a little +1 here. So basically whatever the denominator is, you're going to add 1 to get your numerator. So 6, that'll be 6 plus 1, which is 7 pi over 6, 5 pi over 4, 4 pi over 3. Okay, now this last one is a little bit tough to see what that pattern is, but think about how we would get the numerators there. It's not too obvious, but pause if you want to think about it. Okay, so here, 5 pi over 3, what's actually happening is you're going to take your denominator, you're going to multiply it by 2, and then you take 1 less. So for instance, the 3 right here, 3 times 2 is 6, minus the 1 is the 5, which is what we have in our table. If you take 4, if you double it, you get 8 minus 1, which is 7. If you take 6 and you double it, you get 12 minus 1, which is 11. Okay? From my experience, that seems to work for the majority of students. But again, everyone thinks differently. So you do what works best for you. Okay? So for instance, if you want to do it the other way, so like for pi over 4s, that's 1 pi over 4. That's 2 pi over 4, which is just pi over 2. Wow, my pencil is acting really funny. That right there would be 3 pi over 4, 4 pi over 4, which is just pi. 5 pi over 4, 6 pi over 4, which reduces to 3 pi over 2. 7 pi over 4, and 8 pi over 4, which is really just 2 pi. So if you want to count that way, you can do it that way too. Okay? As long as you can get the first quadrant, everything else should flow. Okay? So there you go. Pause this here and then go ahead and try to reconstruct all of the radians now. Okay? Try to do it from memory. And if you get stuck, you know exactly where you need to work on. So just do this on your own real quick without looking at this video. So minimize it and then go ahead and spend maybe 2 or 3 minutes on it. Okay, so you've had a chance to do degrees and then radians, right? So now what I want you to do is, I'm erasing it. But what you want to do is you want to scroll down to, you want to flip to a page where there's a blank unit circle, okay? And I want you to do it again, okay? So now degrees, do all of your degrees and then do all of your radians. This should take about maybe 4 minutes, okay? So try it one more time and then press play when you're ready. Okay, so here we go. So I'll do this in real time so you know kind of what you're aiming for. So for degrees, I have 0 degrees, then 90 degrees, then 80 degrees, then 270, back to 360. Okay, then I do the halfway points, 45 degrees. If I keep adding 45, I get 135 over here, 225 over here. I get 315 over here. Okay, to get the other angles, I just go forwards and backwards. So backwards from 90 would be 60 degrees. Forward would be adding 30, so that's 120 degrees. This would be 150, going back from 180. Going forward from 180 is 210. Back from 270 is 240. Forward would be 300. Back would be 330. Forward would be 30. Okay? All right. So now we have radians. That's 0 radians. That's pi over 2, pi, 3 pi over 2, and 2 pi. Okay? I know that this is 643. Pi, pi, pi. So this is 643, 3, 4, 6. 6, 4, 3, 3, 4, 6. I'm going to go ahead and put in all the pi's here so I don't forget. Pi, pi, pi. Okay. And then I know in quadrant 1 I have to subtract 1, so this is going to be 2, 3, and 5. In quadrant 3 I know I'm going to have to add 1, so that's going to be 7, 5, and 4. And fourth quadrant I'm going to have to double it, then minus 1, so that would be 5, 7, and 11. Okay. Now, obviously, it's going to take a lot of practice to build up that speed, but again, work on accuracy and then work on speed. All right? So that's it. Your job is to figure out the degrees and the radians. So now on this unit circle, at the very least, you guys will know what the conversions are. For instance, if someone asks you, what's 135 degrees in radians, you'll know exactly that 135 degrees is 3 pi over 4. Okay. Similarly, if someone tells you, well, what's 7 pi over 4 in degrees, you could take a look. 7 pi over 4 degrees, that's 315 degrees. So this unit circle really gives you an organized way of seeing which common angles and what they convert to. Okay. So that's it. Practice that and then go ahead and take a look at what your assignment is and go from there.